What a great conference, right? This is wonderful. We are really excited to be here, so thank you very much. We're going to be talking about AI. Who out there is using Copilot? Copilot, okay. Maybe Cursor AI. We've got a fair amount of people. All right. ChatGPT. Mike and I, here's something that you might not know about us. We call it Jippity. I don't know, is that something, I don't know if that translates to Italian, but we call it like, it's like our friend that we hang out with. And while they're getting the screen set up, I'll continue to burn some time here. Mike and I do a consulting company called Live Love App, and we've been working with clients the last couple of years integrating AI into their apps. And one of the things that we learned about this is that there's an opportunity here to build something for the Angular community that allows Angular developers to really build some unique concepts inside of AI. And so we think that AI is transforming the way that we all work. Like I mentioned, Copilot is transforming the way that we write code. Jippity is transforming the way that we seek answers around code, right? We say, hey, explain this to me, or help me solve this problem. And Jippity is able to go and figure out, based on its knowledge, and search the web, and kind of come back and give us some solutions. And so we started thinking, maybe there's something here, Mike. What do you think?
Yeah, I mean, it was actually 2 years ago when I was here for NG Rome that ChatGPT came out. Like, it was like a week after that NG Rome. And I was in the Amalfi Coast with my fiance, and we just could not stop playing with it. Like, the next 2 weeks of our Italy trip, completely dominated by ChatGPT. So as soon as Brian and I got home, we're like, we have got to figure out, like, what is this? Yeah. How can we use it? And that's the first time we started building apps with AI. And we've just been experimenting over the past few years, trying to figure out, well, where does this really fit in to our developer tools? And that's really led us to this big question that we're trying to get an answer to, and we want to show you some of our thoughts. What could Angular apps look like if we had intelligence built into them? Not using intelligence to build the apps, but to actually make the apps better, friendlier, and more accessible to users through intelligence. But before we get into some of those answers, let's do some introductions. So yeah, my name is Mike Ryan. I'm one of the original co-creators of NGRX, and I'm joined by Brian.
Yep, I'm a Google developer expert in Angular, and I love pasta.
And you can
and
find,
pizza.
And definitely pizza.
It's all of it.
We have our own little consultancy called Live Love App. That's been where we've gotten to do a lot of our open source work. And so, yeah, through this consultancy, we've been exploring this idea of generative user interfaces.
Wait. Generative user, what are you talking about, Mike?
I know. It's kind of a newish term. And the idea is like, generative AI is the broad concept, right? And we use generative AI to get answers in ChatGPT. We use generative AI to generate code, maybe with GitHub Copilot or Cursor. So generative user interfaces is the same idea, but for UI. We're going to take generative AI, and we're going to dynamically create user interfaces on the fly with this intelligence.
This is interesting. So we're not talking like NG template, kind of, but not really. So the LLM is going to generate the UI?
Yeah, definitely.
All right.
Bear with me. It's going to take us a little bit. We're going to go from really, really small idea, and we're going to get bigger and bigger and bigger with it. And I hope you're able to join us for this journey. And part of our exploration has led us to create a new open source library that we call HashBrown. HashBrown is a completely free and open source framework for building joyful, generative user interfaces in both React and especially Angular, Angular first. And I want to highlight, again, open source. You can go contribute to this project. It's available on GitHub, and we really want to build a community around it. In fact, we've already got a number of contributors that have been helping us bring HashBrown to life. And so if you get to the end of this talk and you're like, I really want to work with Mike and Brian, we want to work with you. Like, yes, please come help us build HashBrown. So here's how it works in terms of integration. Here's how you get started with HashBrown. So you're going to bring your own backend, and you're going to pick a HashBrown adapter for whichever AI provider you want to use, whether it's OpenAI or Google's Gemini models or Writer. That adapter package is going to communicate with the large language model, and it's going to form hardened streaming responses that are ready for your web apps to consume. From there, HashBrown's Angular SDK is going to consume those streaming messages and expose them to your Angular components and services. It gives you chat state management, structured data capabilities, and even a JavaScript runtime to dynamically run JavaScript generated by the LLM.
That's a lot, Mike. I think we need to break this down a little bit.
Yeah, so you can use this whole concept to create AI-powered services and components. So like I said, let's start small. For us, we love the new Signals API, and especially the new resource interface that was just exposed or introduced in Angular 20. And so HashBrown uses signals and resources out of the box. Everything that we are going to show you is going to be using these new interfaces. So let's start with completions for form inputs.
Yeah, so has anybody used Gmail? You're starting to write an email, and it kind of suggests, like, here's the rest of the thing you might want to complete it with. Yeah, I'm seeing some heads nod. Yeah. So what if you could put that same thing in your Angular app, right? It'd be pretty nice to do that. You might have like a text input, you're building like an enterprise app, and the user might be entering data into this application frequently, and what if you could just suggest that this might be the thing that they want to enter into a text box? Well, we all know with LLMs are really good at predicting text, right? An LLM is basically a giant knowledge base that's been trained, and then it takes that knowledge base based on the context that you give it, and it starts to generate out the next sequence of characters. So it just knows what might come next. So this is a great use case for building text completion. Let's take a look at a demo.
Yeah, to show this off, we've got a smart home app. So this has got all of the lights that are in my apartment back in Portland, Oregon, and I have some scenes that allow me to control these lights. And so you can see that one of the lights that I have here in my living room are these like entertainment ambient lights. And maybe I've just went and purchased a new smart light and I want to get it configured in my system. Well, I can go add a light, and as I start to type it in, it'd be really helpful if the LLM could actually see what I've typed and then offer me suggestions and completions in any of my Angular inputs. So you can see here that I've typed in living room entertainment M, and then it completed the rest.
That's pretty good.
And I can just hit tab to accept that completion.
Yeah, but that must have been a lot of code, Mike.
This is the smallest demo we'll show so far. So let's go through the code and kind of break it down.
Okay.
So like I said, with HashBrown, everything that you want to consume is going to be done through a resource. And we're going to start with the smallest resource. We call this a completion resource. The idea with the completion resource is that you're going to give some data to an LLM and a set of instructions, and it's going to generate some text as a result of that instruction and that data set. To use a completion resource, first you're going to provide the name of the model that you want to use. So for example, if you're using HashBrown's Google Gemini adapter, then you would pick any of the Google Gemini models and place it right here. In this case, we're going to use Gemini 2.5-Flash, which is a small, efficient, and smart model. Next, you're going to provide what we call a system instruction. And this is, I think, one of my favorite parts of AI engineering is that most of the programming you're going to do with HashBrown is not going to be Angular code or TypeScript. Most of the code you're going to write is just going to be plain natural language. You're going to tell the AI what it is you want it to achieve for you. This is the instruction to the LLM. So here we're saying, you're going to help the user generate a name for the light. We're going to give you the current input, what the user's typing, and we're also going to give you the list of all the names that they've already chosen from the existing lights. Output only the next text segment. Don't give me any extra words or explanation, just help them complete it. The third and final parameter required for the completion resource is the input. And again, this is all signal-driven. So I'm going to use computed to give the LLM some data. First, I'm going to give it the input. And this is whatever the user is typing in to that text box. So as the user types, this computed is going to be automatically updating. But we also want to give the LLM access to all the names that have already been chosen by the user. So we're going to give it all the light names as well. And like I said, we're doing this in computed, so this is going to update every time either of these two data sources change, allowing those predictions to be generated on the fly. So that's the completion resource. And like I said, that one's data in and text out.
Yeah, but what if we want to get data out of the LLM? How do we do that, Mike?
So you want more than just text? Like I'm using ChatGPT and it's just text.
Yeah, but ChatGPT is pretty smart, right? We got to be able to get JSON out of this thing. And as a developer, I want to take natural language that a user might provide through my application, but I need that like parsed. I can't just accept text. I might want to have like an R rule if I'm creating a calendar invite, or I might want to have like JSON or structured data that meets my needs for my application, or then I might want to persist into my database.
Yeah, you're absolutely right. And Hash Brown supports this out of the box. Let me show you a demo, then we're going to jump into some code. So I'm not going to create this light just yet, but I'm going to go create a new scene for my apartment.
Okay.
And if I were to create this scene, let's say I wanted to create one that dimmed all the lights in my living room to 30%. Well, in a traditional app, we have to provide users these complex forms because we want them to give us structured data. So you can see here that Brian is going through and selecting all the lights one by one, adjusting the brightness, and configuring the system. But with AI, we can accept natural language as an input and turn it into structured data. So instead of selecting these lights manually, what I'm going to do is I'm just going to say dim living room to 30%. And then we're going to use the AI to take this name and automatically suggest to the user what light should be in it.
That was nice.
So you can see it's suggesting that I add all the living room lights to this scene. So that sounds great. I'll just go ahead and add them. And now I've got my scene configured to go. I didn't have to interact with a complex form. I can just accept the natural language from my user and put it right on in.
I think it's really powerful that LLMs are able to take natural language, and then we can kind of tell them, hey, LLM, give me back this as a structured response. But I've got to be able to tell the LLM what that structure looks like, Mike. Am I going to use some sort of schema language, or what would I do in order to do that?
Yeah, let's take a look at some code. I'm sure you're curious to see, how did we get this to work? So instead of a completion resource, now I'm going to use Hash Brown's structured completion resource. This is for getting structured data out of an AI model. It starts the same. You pick a model that you want to use, and then you give it again that system instruction. This time we're saying, predict the lights that will be added to the scene based on the name. For example, if the scene is dim bedroom lights, suggest adding any lights that might be in the bedroom at a lower brightness.
That
Pretty
makes
simple
sense.
instruction.
And we saw this before. Here's our input, right? So before we were providing input to the LLM, and we gave it a computed signal. This time we're giving it input of the scene name, as well as all of the lights that are in our application. So we're giving it a little bit of state, you might say.
Yep. But then from there, we need to get structured data out. So we need to describe some mechanism to actually get real data out of this LLM. And to do this, we've written our own schema language that we call Skillet. We think it's one of the first LLM-optimized schema languages. And what it does for you is it gives you, first off, really strict type safety. All the schema that you write with Skillet is going to be really strictly typed. You're going to get great TypeScript intelligence when you're using Skillet schema with Hash Brown. It's also highly descriptive. Unlike other schema languages, Skillet makes all the descriptions part of the API. That way the LLM knows not just what kind of data to generate, but what each part of this data means. So you can see here that we're telling it we want an array of lights to add to the scene, and we want to join between a light and a scene in that array, and a light ID and a brightness. It's very descriptive. That way the LLM can succeed at generating this JSON.
We also get really clear error messages out of this. So because we've written our own schema language that's LLM optimized, we can optimize the LLM and inform it when errors happen so the LLM can respond accordingly. And of course, you're going to get good error messages out of it as a developer. And finally, we have built what we think is possibly one of the coolest things. We have a streaming JSON parser. Now, that's a lot of lingo, so hold on. Let's just do a quick demo and show you what that looks like.
Yeah, so I'm going to go back and note what I'm going to remove these lights real quick.
And let's do 50%.
When I do 50%, it cleared, and now we're waiting.
Waiting.
Oh, there's our suggestions.
Yeah, but we can do better. We have a reactive framework, and we have signals that are updating live, and Angular is great at reacting to signals as they're updating. And we just render the DOM over time as the data is being streamed from the LLM, just like you're used to in ChatGPT.
That's right. So if I go into my code editor now.
This is going to be really complex, I have a feeling. I mean, we're going to have to go in, we're going to have to start parsing things and eagerly checking for stuff. I don't know what we're going to do here, Mike. This is going to be tough.
So here's my schema. And as the LLM is generating this JSON, I actually want each object as it gets emitted. So I'm just going to drop that streaming keyword on here.
That's it?
And now I'm going to go back, and when I had the scene, dim living room to 30%, Now instead of waiting, we're streaming the suggestions in as the LLM has generated it, letting us get results to the user far faster than waiting for the whole response.
We think that streaming is really a core part of using intelligence in your Angular applications. We know that LLMs, some of the models are faster or slower, kind of depends on what you're choosing, depends on how much intelligence you need and these kinds of things. But we think that streaming is core to the user experience. So that way, as the streaming is coming from the LLM in chunks, we can start to eagerly parse that JSON and start rendering things into the browser in real time as the LLM is responding. So we've baked streaming literally into the core of Hash Brown with a nice thing called Skillet.
So to get started with Skillet, first, you're going to plug it in to any part of Hash Brown that accepts a schema. And you're given a Fluent API for describing the types. We support all the basic types of JSON: strings, booleans, numbers, arrays, objects, nulls, and so on. For every node in the schema, you have to give the LLM a description of what it is. That way it knows how to match that schema. Like I said, it supports objects. And again, you kind of pull this all up into these objects with all these descriptions. And then finally, you can wrap this all up in arrays or whatever kind of data type you want. And one of the nice parts of Skillet is that unlike really big schema libraries like Zod, which try to do everything that TypeScript can do, Skillet is actually limited to all the things that LLMs can do.
Which is a subset of all of that.
Very, very small. Yeah, LLMs can do only a fraction of what TypeScript can do with its own schema, for example.
Sure, that makes sense.
And as we just showed, if you want to make any part of this streaming, you can just throw the streaming keyword on it. The streaming keyword is supported on objects, arrays, and strings, and it can be deeply nested throughout the entire schema.
Nice.
So that's the structured completion resource. Now let's keep kind of building on top of this.
Let's keep going. Let's do this.
So, like, filling out forms is cool. It's nice that we can maybe give users autocomplete on these text inputs, and we can give them suggestions as they're filling out forms. But I don't know, I kind of don't even want to use a form anymore. It would be great if the app were suggesting to me or predicting my next steps and giving me the ability to just go off and do it without having to even interact with a form.
All right, interesting.
So I'm going to go ahead and clear this out, and I'm going to go back to my lights. And like I said, I want to add that ambient light 3 now. So I'm going to type it in here, and then I'm going to go ahead and accept this completion, hit add, and I would normally have to go into each of those scenes that controls my living room and edit each and every single one of them. But with Hash Brown, we've actually generated some predictions directly to the user. So now that you can see that Hash Brown's suggesting, hey, to the user, maybe you want to add this light to the living room's chill scene, and to the off scene, and to the on scene. And I can just go in here and accept these. Like, I don't have to do anything. I don't have to go into those forms. And I've been sped up as a user of this app through general or through AGI.
How are we doing this, Mike? I mean, come on, dude. So the user's taking actions. Wait, actions.
Actions.
I wonder what's going on here.
Maybe you've used a state management library,
I
a little
think I
one
have.
like maybe like NGRX that's really action-oriented. Who could say? Might be possible. So we can actually take advantage of our state management libraries that are action-oriented like this. So here I'm using a structured completion resource, and I'm choosing Jippity 4.1, a slightly smarter model to help do these predictions. And my input this time is actually going to be the last action that was dispatched to my NGRX store from some user action. And additionally, we're going to give the LLM some context. We're going to give it the list of lights and the list of scenes. And we're going to use the untracked function from Angular. That way, this computed only runs when the user dispatches a new action, not when the list of lights or scenes changes. So when the user does something, we say, hey, AI, the user's done this. You should give us some predictions of what comes next. And in fact, that's exactly what the system instruction for this one does. It informs the AI that you're going to give us some suggestions. Don't tell them to buy new hardware, but also, like, here's some rules to follow as you're doing this. And the schema now are just NGRX actions, actually.
Whoa, wait. The AI is dispatching actions?
Well, it's not dispatching actions, it's generating actions for us.
Nice.
It's generating new actions so that it can suggest adding scenes to the system or adding lights to the scene. And what we can do in our Angular template is we can just take the output from this signal and we can just, like, for over it, like do a for loop.
Yeah.
We'll use a switch statement for each action type, show a nice little card to the user, and when they hit add, we dispatch that action to NGRX. And now we've built an entire predictions mechanism for our app that helps speed users up.
I imagine there's some good hygiene required in order to do this, Mike.
There's going to be a little bit of structure
I think
you might want
talked
to follow.
about that. Okay.
Okay, that's structured.
Okay, so we did data in, text out. We did data in, data out. We hooked into the NGRX action stream, and based on actions that the user is taking, we're predicting follow-on tasks and actions that the user might want to take next.
That's right.
So this app is getting more and more intelligent.
Yeah. And the next thing that we want to show you is building chatbots. Now, there's like a lot of buzz right now around adding chatbots to apps. And we like them just fine. We think of them as being maybe kind of like a command line tool for users or power users. And Hashbrown certainly supports building chatbots. So let's take a look at what that might look like.
Yeah, let's do a demo.
So in this app, there is a chat, and I can say hello to it. And the LLM is going to respond and stream a response back in, assuming the Wi-Fi in here works. Great. Hello, how can I help you today? Let's take a look at the code that powers this one. So previously, we were using completion resources. And completions were all about taking some data and then giving us new data back out. But we also have chat resources. And a chat resource is for having a conversation with an AI. We don't have to render this as a chat. And we're going to show some ways that you can use chat that doesn't even look like chat a little later on. But for now, kind of follow along that with this chat resource, you give it a model and a system instruction. You can also give it a debug name, and we're going to show that in just a second. But to send messages into this resource, you just take the resource and call send message on it with the content of the user's message. This is all that it takes to start building a simple chatbot. But like this isn't super helpful because all I can do is talk to it. It can't really do anything for the user or help the user in any meaningful way. That's why we've implemented tool calling directly inside of Angular.
Hold on, we got to stop here for a second. Tool calling. So right now, so far, we've got a chatbot, and we're sending a message into it, and it's responding accordingly. But we might want to give it some more context, right? And we might want to, we could stuff that in the system, and we could say something like, hey, the current lights in my system are this, or the currently logged in user is this, or something like that. But LLMs and OpenAI and Gemini come with something called function calling. So function calling works in such a way that you tell the LLM up front that these are the following functions that are available to you right now. And here's the signature for those functions. And then it'll decide when and if it wants to invoke that function. It'll send a message back to you, and then you're going to basically handle that function, invoke it, get the data, and then send that back to the LLM. So it allows you to kind of asynchronously provide more context to the LLM through something called function calling. So you can see here that what Mike has done is he has provided a tools array. So when you create a chat resource with Hashbrown, you can provide it any number of tools. And to create a tool is really simple. We export a function called createTool. You give it a name. Now, you got to give it kind of a helpful name so that way it knows what to call when it wants to call it, as well as a description. And that's a nice natural language description of what this function does. And here you can see that Mike has written a handler function. And this is an async function. Now, you're also going to notice that I'm using the inject function. So this handler function is going to be executed in the context of dependency injection. So you can inject any Angular service or any, like a store or a service or whatever you want in that particular context of Angular. So here, we're injecting the smart home service. And then we're just going to return out the lights in our smart home.
So I'm going to hit save on this, and now I'm going to go back to my chat agent. And I'm just going to ask it a question about the lights here. So let's say, I want to know what lights are in the living room, for example. And so I've asked it the question, and now it's going to go through, it's going to call my service layer, and you see that it's responded with all the living room lights that were in my Angular app.
That was nice. And good Italian, by the way. I didn't even know he was going to do that.
I saw you
I was
wait,
like,
wait, no.
You're messing up, dude. That was good.
Now, debugging this can be kind of a bit of a challenge.
Because I'm getting calls. It's saying, hey, call this function, and I'm doing something. And what data am I sending back to it? How do I know if I'm sending the right data, Mike? I wonder if we could use like a common dev tool that the community is already comfortable with that does time-based debugging.
Yeah. So by providing any hash brown resource with a debug name, you can open up the developer tools and actually use the Redux DevTools extension to understand what happened. So you can see here that I have now in my Redux DevTools all of the state for this particular chat. And if I dive into it, we can actually kind of go in and see what's occurred as part of this flow. So the first message in my chat was from the user, and it asked what lights are in the living room. But then the second message, this is the interesting one. The assistant, it didn't respond with any text. Instead, it responded with some tool calls. It said, hey, I want to get the lights to help me understand how to answer this user's question. It called our Angular service on our behalf, and then we sent to the LLM all of the lights that are in the app. Once the LLM had access to all that data, then it was able to generate a nice response back to us and told us about all of the lights that exist in the application.
Pretty cool.
But this is just for getting information. Like, what if we want to let the LLM do something on behalf of the user?
I would love to see, like, let's say I'm the project manager. This is great, Mike. What if the user says, hey, I want to, like, turn off all my bedroom lights?
Yeah.
How am I going to deal with that?
So Hashbrown comes with a separate function called create tool with args. And here, again, you give it a name. I'm going to call this control light. But this time, you give it a schema. And again, you're going to use Skillet to define what arguments you want the LLM to generate that's going to get passed into
your
this
function.
So yeah, we're going to call this the control light tool. I'm going to go ahead and accept some of these completions here.
Description.
We also need to provide it with, a description. So this is going to let the LLM control a light. Now that I've provided the schema, like I said, Skillet is all about strong type safety. So if I hover over input here, we can see that we're actually getting a strong TypeScript type of what the LLM is going to generate and pass this function.
You did say it was typely nice and strong. I like this. Good developer experience here.
So I'm going to call my smart homes control light method, and then I also want to notify my NGRX store that something has happened here. So I'm going to also inject the store here real quick, and then I'm going to dispatch that the AI has done something on the user's behalf. Now that I've done that, I can go back to the app, open up the chat, and I'm going to say something like, turn off the living room lights. This time it's going to first get all the lights that are in the app, and then it's going to look at which ones might be in the living room, and then it's going to call that control light tool on our behalf and turn those lights off. Hopefully with some Wi-Fi working for us. There it goes.
Yep,
okay.
there it goes.
Just had to touch it a little bit. So you can see that all those lights turned off, and we actually saw it in our app, and the LLM has responded to us. Again, we can dive into this and understand exactly what the LLM did at each step. So the user said, turn off all the living room lights. The LLM then went and grabbed all of the lights that are in the application. Once it got all of the lights, it then chose to, for all 4 of the ones that are in the living room, call control light on it. Once all the lights have been controlled and turned off, we saw the UI update on the left, and it generated a response back out to us.
Very nice.
So this allows you to build chatbots that aren't just like able to respond to the user, but that are able to actually call our Angular service layer. They can control and do things on the user's behalf, and we can see it update live in our Angular app as they're interacting with it.
There's some really good use cases we've seen with this. We've built some for clients. I can imagine, hopefully your minds are starting to think, wow, what could we do with this? Whatever application you're building, you could integrate a chatbot. Think of it, again, as like almost like a terminal or a command prompt for your user to actually be able to control the application. Let's say I'm building like a stock market application, and I've got a big data table with lots of stock symbols in it. And in that data table, I've got things like performance and the last value at close and these kinds of things. Now imagine a user coming in and using your application. They might be interested to say, hey, I want to see the top 5 performing stocks in the last 24 hours with a certain margin and a certain close value. And they're going to go in and they're going to start clicking around and filtering and ordering and sorting and pinning and maybe paginating or whatever that looks like. That's a lot of work on a user. But we think with generative UI and using LLMs and hash brown, all that can go away. The user can just ask in a natural language, just like I did to you already. And you could control that grid, make all those changes for the user, and the user will instantly get to see that.
Cool.
We got to get cooking.
Yeah. Y'all cool with this so far? Following along? All right. We're going to keep leveling it up because we're only about halfway through this so far.
We got to keep cooking.
Tool calling's great, but would it be better if chat wasn't just text? Like, it would be so much more interesting to me if chat was actually responding to the user with my Angular components instead of text.
What if the LLM was actually like building components live? So what I need to do is we're going to go ahead and switch this over from simple demo, and then let's go back. We're going to do the demo first, right?
Nope.
Or we're going to do the code first.
So here's the UI chat resource. A UI chat resource is just like a chat resource, except instead of responding in text, it's going to build Angular components on the fly for us. So just like before, I've given it a model, and I've given it a debug name that we can get in some debugging, along with a system instruction that kind of tells it all the things that it can do. But what's different now is I'm going to give it a list of components that I'm allowing the LLM to generate for me in response to the questions or messages that get sent in. So you can see here that I'm exposing components using this expose component function. I give it the Angular component that I want to expose, along with some metadata that helps the AI understand how to actually use this Angular component. So I just installed this Markdown component from NGX Markdown, just on NPM, and it has a data input, and I'm telling the LLM that I want it to bind a string to this data input. And don't just bind it to it, make it a streaming string.
Stream it in.
And all this is really type safe. Like if I had mistyped this, I'm going to get an error. If I had chosen the wrong data type to bind to it, again, I'm going to get an error.
Nice.
It's really type safe. I've also exposed a light component, so it knows how to show lights to the user. It knows how to put lights in a list. It even knows how to draw scenes. So now that I've done this, let's see if it works. So I'm going to go back to my app, and now I'm going to ask a question. What lights are in the living room? It's going to fire off the same sequence. It's going to call the get lights tool, but now instead of responding in text, it streamed an Angular user interface right back to me.
Wait, are these like actual Angular components?
Oh,
or
yeah,
this
like
just HTML and CSS?
No, like these are the real. Control them, interact with them. What scenes are in here?
Yeah, all right. Let's do it.
Okay, it got our scenes.
Called our function.
And now there's all my living room
I like
scenes.
chill. Let's go with chill.
Chill, sure.
Nice.
I'll apply the chill scene.
Feels good.
And so this lets you build chat that no one on the web is building today. Because every chatbot I've ever used is just really boring text. But with hash brown, you can build chatbots that are responding in rich user interfaces back to the user.
I think it's also really important to note that we work with a lot of financial institutions, and compliance, regulation, authoritative responses are really important. And it's great that as we build this, these are actual Angular components that you've authored, you've tested, and that you can trust, right? So you're exposing the component out to the LLM. It can use that component to generate UI in your application. These are components that you could trust. They're authoritative. And so you're taking your components and using them inside of your experience and allowing the LLM to dynamically generate the UI based on the things that you've built and tested and trusted.
Cool. So let's keep building on top of this even further, because LLMs aren't just good at writing text or generating structured data, and it's awesome, I think, that it can now generate Angular components for me. But one of the ways that we have all experienced AI is its ability to generate code. And so that got us thinking, what if we let the AI generate code and then ran that code in the browser?
Well, that seems like a bad idea.
Like, surely that's a bad idea, right? But
feels like a bad.
what does that mean? And so Hash Brown actually comes with a solution to this problem, or at least experiments with this idea. You see, LLMs are commoditizing simple code. It can't really do big, complex code, at least not in my opinion, and I use these tools on a daily basis. But for really simple glue code or boilerplate code, the AI is really good at generating values or JavaScript that actually meets those requirements or specs. And so we're wondering, like, what could we build as Angular developers if we just asked the LLM to generate some JavaScript on the fly and then ran that as part of our Angular app?
Okay.
So to do that, we first need to give it a runtime. Now, we don't want to just do like eval on a bunch of JavaScript. That would be so terribly dangerous. Please don't do that. And so instead, we've thought about this and try to make this as safe as possible to do in your Angular apps. So first, you create a runtime, and you have to tell that runtime how to load the WebAssembly that powers it. Yeah, WebAssembly. You see, we've taken Quick.js. It's a C-based JavaScript runtime, and we've compiled it to WebAssembly. That way, we can safely run all the LLM-generated JavaScript in a sandbox. This means that out of the box, it can't access the DOM, it can't make network requests, it can't really do anything particularly useful, but just the basic features of JavaScript.
But what we can do is we can provide it with additional context. Oh, the next thing that we're going to do is just like we saw before with tools. So instead of creating a function, what we're going to do is we're actually going to create a tool called JavaScript. And we're just going to provide it with an instance of the runtime.
So why would you do this? Well, one of the things that LLMs are really bad at is math. You see, LLMs are just tools that predict text.
Possibly the next thing.
They don't actually perform any math on their own. And the people who have created LLMs, like OpenAI and Google, they know that this is a limitation with these models. And so what they've done is they've trained these models to reach for a Python VM.
That's right.
And you might have actually seen this when you use ChatGPT enough. If you ask ChatGPT some mathematical questions, you'll see it do something like write some Python and run it inside of a Python environment. Well, we've taken complete advantage of this training instruction and have instead provided it with a JavaScript VM to do the same thing.
So what if we want to know the average brightness of our lights? Without tool JavaScript, the LLM is going to probably hallucinate and just guess. But with tool JavaScript, it can actually get all the lights, get all the brightness, write a function, reduce that down to a single value, just like we would write in JavaScript. We can run that, execute that inside of a safe sandbox environment, provide that value back to the LLM, and it's going to respond and say, I know exactly what the average brightness of your lights is.
So we'll dive into this, and you can see that I asked what the average brightness is, and it ran a couple of scripts to try and perform this. And it called that tool JavaScript with some JavaScript directly here. I'm just going to copy this, and I'm going to bring it over to this JavaScript beautifier. That way we can see what it is that it did. You can see that it got the list of lights, and then it just used lights.reduce to figure out what the average brightness was, divided it by the length, and then provided it back. And so when we ran that, we were able to compute the result for the LLM. We resolved it, told it that it's about 74.888, and then the LLM used that to respond to the user with a mathematically correct answer. It told the user it was 75%, and it knew that it was 75% because it generated code and proved it to itself. But it's not just like for doing math. We think that using tool JavaScript allows the LLM to do things like potentially call our services on our behalf. So with this runtime, if we go back to it for a second, Hash Brown gives you the ability to expose functions into that JavaScript runtime that the LLM can call as part of the scripts that it generates. So you saw earlier that it called that getLights function inside of that VM. And the way that it was doing that is we've provided a function inside the list of functions called getLights. This looks a little similar to tools, but one difference here is that you actually have to provide an output schema. And the reason for this is that we turn this into a TypeScript definition on the fly, and we provide that TypeScript signature to the LLM. That way it knows how to call the function and what data it's going to get back out. Additionally, you give it an async handler, just like a tool. And I want to note that this async handler, note that it said await in it. But if I go back and look at the code that it wrote, it didn't have to call await on getLights. And the reason for that is that these runtimes are synchronous inside, but asynchronous outside. So the LLM doesn't have to worry about writing JavaScript that does asynchronous control flow or asynchronous error handling. That might be a little too complex for it to succeed at. And so what we do is whenever you provide a function to our runtime and we call it, or the LLM writes a script that calls it, we suspend the runtime, we resolve the value outside, let your services run and complete, and then we resume execution in the runtime. That means the LLM can write small, short scripts that it's actually be successful at generating. So with this, let's kind of take a look at maybe a more advanced prompt. Like, it's cool that it's doing some math, but I'm going to say maybe I've bought some new lights and I want to set up a whole new room.
Okay.
I just added lights to my guest bedroom. I have a standing lamp with a top, middle, and bottom bulbs. And I have a desk lamp. Create scenes to turn these off, on, and dimmed to 30%. This would be really complicated to build inside of an Angular app without intelligence. But I'm going to go ahead and pass this advanced prompt to the LLM. And what it's going to do is, I wrote that prompt just a little wrong. I said I just added it, but I want it to add it. So let me try that again. And I'm going to say add lights to my guest bedroom. Now that I've hopefully worded that correctly, it's now running a script. And this script is going to call my Angular service layer for me. And you can see that it's created that desk lamp for me, and it's created those bottom standing lamps as well. It also created all the scenes and then responded to the user with an Angular UI that gave them all the data that it just generated. And so you can build really complex chatbots that can orchestrate your entire Angular service layer for you in response to natural language. So why would I even use a form if I could just write these big complex questions? Just ask.
Yeah, I think it's also important to note here for anybody that's curious is there's also a performance side of this. Because we're actually doing all this orchestration in the JavaScript, in the client, it's faster, first of all, so it's highly performant, but we're also saving on cost. If you did this with a more traditional function calling approach, or perhaps an MCP approach, you're going to incur a lot of token costs. And so because we're orchestrating all of this in the client, in the browser, the user's already authenticated, you don't have to deal with all of that, we can actually do this in a really efficient, performant way that's reducing the costs that you might be bearing as part of the owner of that application and using OpenAI or Gemini models.
Yeah, we can see all the code that it wrote. It set up an entire script for us that takes all these lights, generates them all out, takes those light IDs, breaks it up into scenes. It wrote the whole script. It succeeded at doing it because of the way Hashbrown's runtime works and executed it for us. But we're going to show just one more demo, then we'll get off the stage.
If that's okay.
Because to us, chatbots are so, I don't know, I guess I'm kind of bored by them by this point. And to me, generative UI has to go beyond the chatbot. So I'm just going to show you some ideas of what you might go build with Hashbrown that aren't chat at all. So in another example, I have a set of data, and this data is just some time series data for some products. And for each product, I have the month, and then the revenue that I got from that product, and the total volume that I spent on it. So what I'm going to do is I've built an app that lets a user create a chart from their data using Hashbrown. And you can see here it's asking me, what chart do you want to create?
Let's do a pie chart.
Pie chart? Sure.
Yeah, what would that look like?
Pie chart, what kind of pie chart? Maybe one for total volume?
Sure.
So I'm going to hit create on that, and it's going to use tool JavaScript this time to connect my service layer to chart.js for me. I didn't have to go build this. I'm letting the LLM connect my data source directly to chart.js. And you can see that it's actually aggregated up all the total volume by product.
Can you show me a bar chart maybe, Mike? Now, normally, a user would have to go in, change the chart type, change the date range, filter, add this, add that, configure it. You'd have to write all the code to plumb all that stuff together. But an LLM's really good at writing code. That's cool.
Let's do a line chart by fiscal quarter.
That'd be great. Now it's going to take all that data, and it's actually going to aggregate that data by quarter, compute the data, wire it up to the chart, display the line chart, configure it, and then we're going to take that with Angular, draw that chart out in the browser.
You can see it's Completely combine that all by
Mike,
quarter.
can we put the legend on the bottom?
Of course.
We just got an email with a request, and the PM said to put the legend on the bottom. Can we do that real quick? Is that
of course. Yeah, I'll just
is that
ask it
easy
real
to
quick
do?
to do it. Like, this would be so complicated to build
What,
an
like
Angular
2 story
UI.
points? What do you think?
Oh, there it
Oh,
is
shit,
now at
it's
the
done.
bottom. I hate these colors. Please use gray for everything but product C. Like, imagine building the Angular form that it would take to actually let your users do this. But instead, with just a little bit of natural language, we can let the user
That's
just
nice.
ask the system to do it and generate UI in response to that request. So that's Hash Brown. We're really excited about it. We don't even know what we're going to get to go build with it. You can
Or
go
what
learn-
you're going to build with it.
You can go learn more at hashbrown.dev. And I want to close with just a few thoughts about this. You see, I've spent a lot of time over the past few years not feeling excited about AI, but actually feeling pretty afraid of AI. Because I'm reading headline after headline of companies laying off engineers because they think AI replaces us, or thinking that they can get cheaper engineers because cheaper engineers can now do more with AI. And I'm telling you, those companies lack imagination.
I think so.
With AI, there's so much software that we have to go rebuild now because apps can be smarter and intelligent. They are dark without AI, and we need to illuminate them with this intelligence. I think the demand for the amount of software we have to go create and the apps that we're going to go build with AI is
explode.
enormous. So,
And I guess the last thing that we want to challenge you with is, this is the first of its kind for Angular. So we are asking you to go out and use this. Please try it out. We want you to pioneer generative UI in Angular apps today. Go home, use HashBrown, get your boss to give you a day or two to check it out, build something really cool, show it to him, go get a raise, and grow your company. We think that this is amazing, and we want to challenge the Angular community to pioneer generative UI in the front end using large language models and AI.
so what will you build? Thank you.
Thanks, everybody.